Hey everyone! Today, we're going to tackle a super powerful tool in calculus, integration by partial fractions. Now, I know, the name sounds heavy, but trust me, it's actually one of the easiest, most step-by-step ways to solve integrals that look really, really complicated. So, let's jump right in.
Think about it. When you see a post go viral on Instagram, it's never just because of one thing, right? It's always a mix. A great photo, a super catchy caption, and all the perfect hashtags working together. To figure out why it worked, you have to break it down. Well, integration by partial fractions is the exact same idea for math.
So that leads us to the big question, right? How do we take a messy, complicated-looking fraction that we need to integrate and break it down into simple little pieces that we actually know how to solve? Well, that's exactly what we're going to learn today. First things first, we need to know when to even use this method. Think of it like a special tool in a detective's kit. You don't use it for every case, only for a very specific type of problem, integrating something called a rational function. So what is a rational function? It's just a fancy name for any fraction where you have a polynomial on top and a polynomial on the bottom. You know, something like x plus 1 divided by x squared minus 4. Our whole mission today is to figure out how to integrate functions that look just like this. Now, before we even start breaking things down, there is one super important first step. Just like a detective has to check the scene before they start looking for clues, we have a check we have to do, and this one is non-negotiable. You cannot skip it. We have to check if our fraction is a proper fraction. What does that mean? It's really simple. A proper fraction is where the highest power of x on the top is less than the highest power of x on the bottom. If the power on top is bigger or even equal to the bottom, then it's an improper fraction. And this, my friends, is the golden rule. You have to remember this. The partial fractions method only, and I mean only, works on proper fractions. If you get an improper fraction, you have to do long division first. No other option. You divide it first, and then you can use the method on the remainder part. All right, so once you've confirmed you have a proper fraction, it's time to open up our detective's kit. This next slide is your master cheat sheet. Honestly, you should probably take a screenshot of it because it's the most important tool you'll need. See? This table is our whole game plan. It tells us exactly what to do based on what the denominator looks like. Look at the first type. If you have simple, different factors on the bottom, you just use a over the first one, b over the second one. The second type shows what to do if a factor is repeated, like with a square on it. And the third is for when you have a quadratic that you just can't factor any further. We'll focus mainly on the first two today. Okay, enough theory. Let's put this into action and solve a real problem. We'll start with the most common type, so you can see how the steps work. I promise, once you see it done, you'll see it's just a simple process. Let's take this example. It's straight from the NCERT book. We need to integrate 1 divided by x plus 1 times x plus 2. Now, look at the denominator. We have two factors, they're both linear, and they're different from each other. Ding, ding, ding! This is a perfect match for case number 1 on our cheat sheet. So here's our 4-step plan. Step 1, we write it in the form a over x plus 1 plus b over x plus 2. Step 2 is to find a and b. And here's a super cool trick for this. It's called the cover-up method. To find a, look at its denominator, x plus 1. What makes it 0? X equals negative 1. Now go to the original fraction, cover the x plus 1 part with your finger, and put x equals negative 1 in what's left. That's your value for a. Do the same for b. It's so fast. Step 3, rewrite the integral with these new simpler fractions. And step 4, integrate the simple parts, which are just basic logarithms. Easy. Awesome. You've handled the basic case. Now let's look at the one that trips up a lot of students. What to do when you have repeated factors. But don't worry, it follows a simple pattern, just like the first one. But wait, before I show you the right way, let's talk about the biggest mistake I see everyone make. When students see a denominator like x plus 1 squared, their first instinct is to write a over x plus 1 plus b over x plus 1. Please, please do not do this. It is completely wrong and will get you stuck. So what is the right way? We go back to our trusty cheat sheet. For a repeated factor like px plus q squared, you need a separate fraction for every single power up to the highest one. So the correct form must be a over px plus q plus b over px plus q squared. You have to have both. This is a crucial rule to remember.
Fantastic work! We've cracked both the simple cases and the tricky ones. So now, let's put it all together and write up our final report. This is the complete method from start to finish. Here it is, your 5-step plan for any partial fraction problem. Number 1, check if it's a proper fraction. If not, divide. Number 2, factor the denominator as much as you possibly can. 3, use your cheat sheet to write down the correct form. 4, solve for all your constants, A, B, C. And finally, number 5, integrate each of those simple little fractions. That's it. That's the whole method. You see, the big takeaway here is that solving these problems isn't about being some kind of math genius. It's about being a good detective. It's about following a clear step-by-step plan to break a big problem into small, easy pieces. And with a little practice, anyone can master this. So I'll leave you with this final thought. Now that you know how to break down complex math problems, start looking around. What other things in your studies or even in your life seem huge and unsolvable right now? Maybe they're also just a bunch of simple little pieces waiting for you to tackle them one by one. Thanks for watching and keep practicing.